The cumulative frequency table shows information about the times in minutes taken by 40 people to complete a puzzle. And part A says that on the grid below we need to draw a cumulative frequency graph for this information. The important thing to know when we're plotting a graph from a cumulative frequency table is that we take the upper bound values here as our x values. So look at this entry. The point that we need to plot is going to be 45. The next one is going to be 60, 25, 80, 35, 138, 120, 40. So we're going to plot that now. So with the first one, okay, so that's going to be at 45. So we're going to go from 40 to 5 here. Okay, the next one, 60, 25. So go from 60 up to 25. That's going to be here. Then 80, 35. So here. 138. So we need to be a bit more accurate here. So we know this is 35, 36, 37, 38. So it will be this point here. And last but not least, 120. So 120. And we need to go up to 40. So up here, because it said draw a cumulative frequency graph, we could either make this a curve by smoothly drawing out the points, or a polygon by doing some straight lines between the points. I'm going to do some straight lines between the points because it's just a little bit easier. So if we connect them up like this, cool, and as long as we get all the points correct, we'll get our 2 marks. So we now need to use our graph to find an estimate for the interquartile range. Okay, so the interquartile range equals the upper quartile and subtracting from that the lower quartile. And what we look at here is quartiles. And the clue sort of in the name, that sort of means in sections of 4. So to find out where we're looking for the upper quartile, we're looking at 3/4 of the way up. And the lower quartile, 1/4 of the way up. So if we have a look back at our table here, we see that in total we've got 40 people. So for the upper quartile, we're going to do 40, but we only want to go 3/4 of the way up. So we're going to times by 3/4, which gives us 30. And for the lower quartile, we're only going to go 1/4 of the way up. So we're going to times by 1/4, which gives us 10. Now we need to go back over to our graph. And that sort of makes sense, because if we're going from 0 to 40, in the middle we've got 20. And the upper quartile is halfway between the upper sections, so it's 30 here. And the lower quartile is halfway between the lower sections, so that's 10 here. So you can sort of just work it out by looking at the graph as well. Okay, so we're going to draw along from our upper quartile 30 to the line. Okay, so that gets us down to here. So 70 minutes. So for the lower quartile line, I'll draw along from 10. And that hits here. So we're going to go down like that. I think, look at that, that's about 45. So from that, for the upper quartile, 70 minutes. From the lower quartile, we got 45 minutes. So therefore, the interquartile range is the upper quartile take away the lower quartile, so 70 take away 45, which equals 25. So here the answer is 25 minutes is the interquartile range. So we get 1 mark here for either getting a correct upper quartile or lower quartile. So if you make one silly mistake, you'll still get a mark. And we get a second mark for getting the correct interquartile range. In the mark scheme, there's a range of values that they will accept as the correct answer. And it depends how you've drawn the graph, whether you've done it as a straight line or a curved line. So they do give a bit of leeway in the mark scheme. Now for part C, one of the 40 people is chosen at random. We need to use our graph to find an estimate for the probability that this person took between 50 and 90 minutes to complete the puzzle. Okay, so 50 to 90 minutes. Starting off at 50 minutes here, we're going to go up and then go along. And that looks there that we've got 15 people, so a cumulative frequency of 15. And then for the upper one of 90, we're going to go from 90, use our ruler to go up to the line, then going to go along. Okay, so our line sort of looks like it's 36.5, but you've got to think about the situation we're in. We're talking about amounts of people, and you can't have half of a person. So I'm just going to round up to 37 there. And as I said in the previous part A, they give a bit of leeway because obviously everyone's graphs is slightly different depending on how they drew it. So to find people between 50 and 90 minutes, what we're going to do is take the difference between the numbers we got, which was 37 and 15, which is 22. And now we're looking for a probability. So if we've got 22 people, and how many people are there in total? 40. So that's 22 people out of 40 people. And there's no need to simplify it down at all, so I'm just going to leave it like that. That's our final probability. So we get our first mark here for finding the difference. Second mark for a probability here. And again, like I said in the previous question, there's a range of answers that you can give depending on your graph.